Now, ideally, a spring should give us a linear graph when we do this, but no real spring is quite ideal. And it turns out that this spring has a mass that's pretty close to the mass of the washers, probably equal to the mass of a couple washers, and it's not a real good spring to use if you want to get a linear graph. So this spring is not ideal for a number of reasons. Whether it is or not, we're going to fit a straight line to this data. Now that's not appropriate. The data doesn't give us a straight line, but to illustrate fitting a straight line, I'm going to do that. And I'm going to use this thin little strap to indicate how we do that. Now I could fit a straight line to the first and last data point. We see that the other data points tend to run below that line. We can get closer to the data points on the average if we fudge a little bit with the direction of this line. Now, I'm not sure I've got the perfect straight line, but I'm eyeballing this. I'm trying to get as close as I can on the average to the points that I've marked on this graph without actually going through any of the points. So I'm going to mark a point at the end of at one end of the strap and a point at the other end. And of course it's a little bit difficult to do that well when you're using chalk. And I'm then going to connect those 2 points with a straight line. Okay, so now the purple line is my best estimate of a good straight line to fit this data. The best fit of a straight line doesn't actually come as close on the average to the points, but it does something very much like that. So let's make that line just a little bit more prominent. So there's a straight line. Now the question is, what's the slope of that straight line? What's the equation of that straight line? Well, we can get the equation of a straight line if we know its slope and its y-intercept. Since the line happens to go through the y-axis, we can estimate its y-intercept. If this is 50, here's 55, it looks like the y-intercept is around 51 or 52. So I'm going to come over here. I'll stay in purple so we know what's related to what. Purple chalk isn't writing real well. Okay. The y-intercept is, let's say, 51.5. That's a little ridiculous to think that we are accurate to the nearest tenth of a unit when we've done something as imprecise as we've just done, but I'll write that down anyway, okay? Couldn't decide between 51 and 52, so I chose 51 and a half. But either 51 or 52, even 50 would have been a pretty good estimate. Okay, now what's the slope of this line? Well, to get the slope, we need a rise and a run. And we're going to get the most accurate result if we use the 2 points that are furthest apart on this line. So if this is horizontal here, we can see that this graph has a rise from 50 to what looks like about 80, or 51 to 81 or whatever. And if we project down here to the x-axis, we see that this would correspond to a little more than 6 washers. 6 washers would only come over to about here, so I'm going to say that's about 6.5 washers. So the run is approximately 6.5 washers, and I didn't actually use this point and this point. I used the intercept of the graph and this point. Now I don't have room to label the rise, but the rise appears to be about 30. So between widely separated points, rise is approximately 30, and that would be 30 centimeters. And the run is approximately 6.5. W stands for washers. Not sure I said that earlier, I should have. So the slope, and I'll say that M equals slope, and that's also equal to the average rate of change of the length with respect to the number of washers, is the rise, which is 30 centimeters, divided by the run, which is 6.5 washers. And what's that equal to? Well, 4 times 6.5 would be 26. That would leave us 4. It's at about 4.6 centimeters per washer. And so what's the equation of the line? Well, we know the y-intercept, we know the slope, so the equation of the straight line would be y equals 4.6x plus 51.5. And that would give us our linear function. And we write the linear function as f of x equals 4.6x plus 51.5, or even better as 4.6 centimeters per washer times x plus 51.5 centimeters.